Welcome back to Logic Basics. We are in the middle of learning how to use the square of opposition. If you recall from last time, we have this handout we're using with a lot of different exercises on it. We are going to start with this A section talking about every neurotic is inhibited. Now, the author, Raymond McCall, asks us to pretend that's true. So we are going to have to sort of ignore the meaning of words, which is not something I usually say, but we need to ignore the meaning of words for this exercise to see how it fits on the square and to figure out whether it's true, false, or doubtful, given the truth of the first statement. So I'm going to go to my iPad where I have put this statement on the square of opposition, and I'm going to teach you how to fit these statements that are kind of messy, like no neurotic is uninhibited. That's a messy statement. Or no uninhibited person is neurotic. How do we get those on the square when we only had those A, E, I, and O statements? I'm going to also draw your attention to this handout, which is the rules for obverting, converting, and doing eduction for a statement to see if it fits on the square and if it's true, false, or doubtful. And then I'm also going to draw your attention to this, what I'm calling the flow chart. So the flow chart will be a tool that we could use for figuring out if a statement fits on the square. All right, but first, let's go to the iPad, and we're going to use these rules. And notice, let's talk about obversion first. The rules for obversion. In obversion, the quality of a proposition is changed without any change in meaning. So remember, we have to talk about quality and quantity. So quantity is how much, universal or particular. Quality is whether it's affirming or negating, right? So we're going to change the quality, affirming or negating, of a proposition without changing the meaning of it. Now, here are some rules, and I'm going to have to talk about these rules. Boy, I wish I could draw on this. I can't because it's not on my iPad. The first rule is negate the copula. What's the copula? Is or is not. Remember, we have subject, copula, predicate. Then we negate the P term. What's the P term? The predicate term. So negate the copula, negate the P term, leave the quantity the same. How much? So if it's a universal, it stays a universal. If it's a particular, it stays a particular. So now let's go over here and look at what the examples look like. So an A statement, all S is P, is going to change to an E statement. No S is P. But we're also going to add negation of the P term. So all S is P is going to change to no S is non-P. Okay? Now, I don't know, this is something you just have to practice. All S is P is going to change to no S is non-P. So we're changing the quality. We're changing from affirmative all is to negative no is. We've kept the quantity the same. It's how much is the same, okay? Universal, universal. No S is P, a universal negative, is going to change to all S is non-P. We have to negate the P term, keeping the quantity the same. So leave the quantity the same. No is a universal, and it's a negative, is going to stay universal, but it's now going to be affirmative. That's the quality is changing. All right, so those are the universals. Now, this tells us A to E, E to A, O is going to change to I, and I is going to change to O. So let's look at this. Here's an I. Some S is P is going to change to some S is not non-P. So here we have the particular affirmative. It's going to change to a particular negative, and we're negating the P term here. Okay? Some S is P changes to some S is not non-P. All right, now look at the O term, or the O statement. Some S is not P, that's an O. Particular negative is going to change to some S is non-P. So a negative changes to an affirmative. particular stays particular. Some S is non-P. Now, Raymond McCall will say a way to remember this, and maybe I can do this on my iPad. I'm going to switch over here. A way to remember A to E. You know what? I'm just going to do this. He says, here, errors are obvious. Okay, errors are obvious. What that means is an E statement is going to change to an A statement. An A statement is going to change to E. O is going to change to I. And I is going to change to O. This is the rules for obversion. We're going to obvert the statement, okay? So, it looks like this. No S is P is going to change to all S is non-P. So we keep the universal, but now it's a negative changing to an affirmative. The P is now non-P. That's for this one. Now this one's going to look like all S is P upverts to no S is non-P. So all to no, we're keeping this the same, and this is changing to non-P, okay? Now, one more I'll show you. Let's take this off of here. Let's do O to I. So O statement says some S is not P. When we obvert this, it's going to say some S is non-P. So notice what we're doing. Is not is changing to is. P is changing to non-P. So we're shifting the negative over to the predicate term here. All right, last one. We'll do one more. We'll do I to O. Okay, so I says some S is P. That's our I statement. When we obvert it, it's going to say some S is not non-P. So the is, affirmative, changes to the negative, and then we negate the predicate term here, right? So that's the rules for obversion. Now, I'm going to go back to this rules handout. When do we obvert something? We're going to, let's see, the flowchart is going to tell us when to obvert a statement. Maybe I'll just show you the rules for conversion while we're at it, and then we can just do some problems. I think that would probably be best. So let's talk about conversion. Sometimes you have to obvert a statement. Sometimes you have to convert a statement depending on the context. All right, so in conversion, the S and P terms are interchanged without change of meaning. So we're going to switch the S and P terms. The order of the subject and the predicate terms are going to be switched. Now here are some rules. First, determine the quantity of both the S and P terms. I haven't told you about that yet. In the affirmative A and I, the P term is always particular. In the E and the O, the P term is always universal. Maybe I should show you that. This is going to be important for future lessons, so I will sketch that out quickly for you, and I will use the iPad again. So let me show you that. We have our A, E, I, and O statements. Please take notes on this. This is important. You're going to do this again. This is all S is P. No S is P, some S is P, some S is not P, okay? So whenever I say A, E, I, and O, this is what I'm talking about. Now, the S and P terms are going to have values to them, and we're going to call them the little u's and little p's. I will use, what color? Let's use blue for this. Little u's and little p's is what I'm going to call it. You do need to know this, so please take notes on this and it'll come up again. So in an A statement, which is, let's do this too. A is a universal affirmative, right? Universal all and affirmative is. An E statement is a universal negative. Universal negative. No is. Okay, so the universality and the negativity is in the no. I is a particular sum and affirmative. So let's put that there, particular affirmative. And the O is a particular negative. Particular negative. Now, each of these has a value to them given their particularity and their universality. So the A statement, the S is a universal S. Why? All S is P. Let's use an example. Let's just say something like, all baseball hats are black. Okay, so maybe someone's wearing a baseball hat, and we'll just make a statement, all baseball hats are black. So that's saying all of the S's, baseball hats, are black. All right, we could make a Venn diagram for this if we wanted to. Here's the baseball hat, and here's black. And this one would say all S is P. So all baseball hats are black. So we would cross out the part where there's not an overlap between baseball hats and black. Now, the handout just told us that in an A statement, the P term is particular. So we're going to put a P here. This P term is particular. Why? Because A statements only run one direction. You can't say, okay, so all baseball hats are black, therefore all black things are baseball hats. Well, this is a black thing and it's not a baseball hat, so that's not true. Oh, look at this now. Here. All right, so the Venn diagram kind of shows us the relationship between S and P and how it only goes one direction. All right, let's see if I could take this off of here. Okay. Now, no S is P. This is going to be good news for us. The S is universal and the P is universal. So here's an example I like to use. No onions are tasty things and no tasty things are onions. It does go both ways. These are interchangeable. It's negative and it's universal in both directions, okay? That's good news for us when we start doing the square of opposition, because we're going to find out when we want to convert something. Some E statements, you can straight convert it. You just switch the S and P terms and then you have your answer. And for the I statement, some S is P. This is going to be P, particular. Why? Some dogs are cute and some cute things are dogs. It does go both directions. These are interchangeable, unlike the A statement where they weren't interchangeable. All right, so some S is P and some P is S. That's how it works for that one. And that's going to be a good thing for us too when we want to convert an I statement. Sometimes we can just straight convert it. Switch the S and P terms and we're done. This O, you can anticipate the O is a tricky O. It's always going to give us trouble. The O we're going to say is PU. O's stink. Why? They trick us a lot. So this is a particular S. Why? Because it's connected to the sum that's particular. And the P is a universal. And so you know what? I'm going to leave that for now. I'll explain to you later when we get to arguments why it's like this and why it's going to give us trouble when we get to arguments as well. For now, I would encourage you to read in the Socratic logic text or in Raymond McCall where they're explaining these values. And I'm also going to give you just a little mnemonic device that I use to help me remember these. I remember that A is UP. So A is UP, E is UU, I is PP, and O is PU. So you can, and what I'm talking about is these little u's and little p's. Okay, so put this in your notes. Remember this. It will come up again, especially when we're evaluating arguments for validity, categorical syllogisms. So put this in your notes. And the context originally was in conversion, the S and P terms are interchanged without change of meaning. And then it tells us, number one, determine the quantity of both the S and P terms in the affirmative A and I. The P term is always particular. In the E and O, the P term is always universal. Now it's telling us for conversion, switch the S and P terms. Do not overextend, meaning do not go from particular to universal. I'll show you what that means. It's when we go from a little p in a premise to a universal in the conclusion. So when we convert, an A statement changes to an I statement. An E statement is going to change to an E statement, and I is going to change to I, and O does not convert. So let me go back to the iPad here for a second. Let me write this down before I forget. A is going to change to I, E to E, I to I, and O does not convert. Now let's switch over to the iPad and I will show you what this looks like. So this is rules. I would write this down in your notes too. Rules for conversion. Converting a statement. Okay, so what this looks like, I'll use blue. A is all, S is P. Now we're going to change it to I because this little p is, so we have a universal S and this p was particular. We need to keep that p particular. So I, remember, is PP, particular, particular. So we're going to switch the S and P terms for this, and it's going to look like, I actually want to draw under it, so we may have to, I'm gonna do it like this. All right, so I, sum P is S. Okay, so the A statement is changing to an I statement. The all changes to sum, and the S and P terms are now switched. And it's because this is a sum because this is P. So when we do this move, we keep that P term particular, okay? That's going to be important. We can't go from a particular to a universal. If we were to go like this, all S is P to all P is S, then we've done something wrong here. This is a universal and a particular. This would be a universal and a particular. So we've gone from a particular P to a universal P here. And that's a mistake. So we can't do that. That's why it has to be sum P is S. Okay. Now that is the A to I statement. What does E to E look like? E to E is beautiful. You're going to love this. We're going to call this the ideal world situation. Ding, ding, ding. Yay. It's easy. We'll call it ideal world. So let's look at this. No, this is this one. No S is P can change to no P is S. Why? Because this is UU and it stays UU. So we could just switch these two. And when we see these, it's going to be beautiful for us. It's going to give us an easy problem. We don't have to do any more work. Okay, so that was E to E. I to I is similar. Let's do I to I. I says sum S is P, and we can convert sum S is P to sum P is S. Why? For the same reason. So here we have our P, it changes to P. So these are just staying the same value, so we can just switch them. And that also will be like, yay, I have an easy answer. Okay, now, this one's going to be super important, and it's going to be the source of all of our grief. So we have happy ones here. This is a grievous one. O does not convert. It's grievous because will struggle with it. But struggling is good. It's how we learn. I'm telling you, you could make mistakes. So O does not convert is going to be the source of our doubtful, what do you want to call them? Our doubtful problems. Okay, so I will show you on the square what happens when we can't fit it. It's usually an O statement that's stuck. It can't be converted. All right, so what did we do? What did we do just now? We went over the rules on this handout for obversion and for conversion. I'm going to suggest you just ignore number 3 for now, full contraposition. I will do it. In our next lesson, I will show you what it is, but you don't have to do it because I'm going to show you a shortcut. Now, eduction, you will do. Now, this is what we're going to do in our next video. So let's read through it, and then I'm going to do it with you. All right, so eduction determines the truth or falsity or doubtfulness of any given statement about S and P. And we're going to find out there's 32 ways to put S and P together. So here's what we're going to do for eduction. We're going to draw and label 2 squares of opposition, the original and its full contrapositive. And that is why on my flowchart I had 2. We're going to fit the given statement onto its nearest square, either the first one or the second one, by obversion or conversion. So we're going to use the rules we just learned, and we're going to evaluate and explain, which means we're going to read from the statement to the square. I'm going to suggest this is a move for the logic enthusiasts. You don't have to do this for the exam, but if you can do it, you are awesome. All right, if it cannot fit on the square, it is doubtful. I'm going to show you those doubtfuls. Now it says be careful to avoid simple conversion of an A statement and other operations on these. Remember, the A statement only goes one direction. The S is a universal, the P is a particular, and an A converts to I. So a simple conversion is where you, what I just showed you, you can't do. You can't go all S is P to all P is S. That is a simple conversion. We're going to say no. This is going to be called what was called the reciprocal. So this is the reciprocal, and it is doubtful. And guess what it is on the square? This is the contradiction of the O statements that can't be converted. So sometimes we'll see this. Some P is not S. That's a doubtful too, because the S and P terms are in the wrong place. They're backwards, but we can't convert it. It's stuck. So the doubtfuls, this is the doubtfuls are either going to be the reciprocal, the contradiction of the reciprocal, or the inverse and the contradiction of the inverse. And I'll show you that. That's on the second square of opposition. So we're getting some clues about where the doubtfuls are and how to look for them. All right, now I'm going to pause here, and when we come back, we're going to take these rules and apply them to our long list of, I have so many things open right now. Our long list of, well, it's somewhere in here. Let me see if I can find it one more time here. Our long list of sentences. We'll start with the neurotics, okay? The inhibited neurotic people. All right, next time, we're going to do the square in all its fullness.